Hello everyone. So today I will be discussing very important examples on counters which have been repeated over many times in GATE. So before that I would like to give you a revision on flip-flops as that is very important to solve those questions. So I will start with JK flip-flop. Initially, if the value of J and K is 0, Q and Q of n plus 1 will be the same. In other words, if my Q is 0 and J and K are 0, Q of n plus 1 will also be 0. And if Q is 1, Q of n plus 1 will also be 1. Same way, if J and K is 0 and 1, no matter what my input will be, Q and Q of n plus 1 will also be 0 and 1. If they are 1, 0, Q and Q of n plus 1 will be 1, 0. And if it is 1, 1, the value will toggle. For example, if my input is 0 and J and K is 1, 1, my Q of n plus 1 will be 1. And if it is 1, Q of n plus 1 will be 0. Next, I will talk about very important D flip-flop. Generally, in counters, D flip-flop is used as it is very simple. We will see how. Now, the value of Q of n plus 1 will directly be dependent on the value of D alone. Let's see, if D is 0 and Q of n is 0, my Q of n plus 1 will be 0. Same way, if Q of n is 1 and D is 0, Q of n plus 1 will again be 0 only. Same way, if Q of n is 0 and D is 1, Q of n plus 1 will be 1. And if Q of n is 1 and D is 1, Q of n plus 1 will be 1. Now let's see another flip-flop called the T flip-flop. There are two cases. Initially, if let me take Q of n as 0 and my T is 0. So here Q of n plus 1 will be same as Q of n. So 0, 0. Now if it is 1, it will be 1 again. This is for the same state when T is 0. Now if the value of T is 1, it will toggle. For example, initially my Q of n is 0 and T is 1. So Q of n plus 1 will become 1. And if it is 1, it will become 0. So you see how the values are toggling. Now in general, as I mentioned earlier, we will prefer D flip-flop only to design the counters, mostly. Now let me discuss some important examples and they will give you a better idea of what the topic is. Okay, so this is the first question. In the circuit shown below, the frequency of the clock signal is 12. So clock frequency is 12. Now they are asking what is the frequency at Q2. Now in my last video, I discussed how the frequency changes based on the modulus number. So here we have been given a circuit but we don't know the modulus number. So we have to calculate that first. Now I will explain a simple method to do that. Now since they haven't mentioned the initial states, I will assume it to be 0, 0. Now let us write the values according to the circuit. So I'll take it as Q1, Q2, Q1, Q2, D1, D2. Now from the circuit we see that D1 is nothing but AND operation of Q1 bar and Q2 bar. So D1 is nothing but, I'll write it on top, Q1 bar into Q2 bar. And D2 is directly connected to Q1. So the value of D2 will be same as Q1. Now based on the values of D flip-flop, we can find the next values of Q1 and Q2. Previously I discussed the truth table of D flip-flop, right? So based on that. Now initially my state is 0, 0. D1 is nothing but Q1 bar into Q2 bar. So Q1 bar is 1, Q2 bar is 1, and operation will give me 1. D2 is nothing but Q1. So Q1 is 0, so 1, 0. We saw that if D1 is 1, my output will be 1. So Q1 will be 1, and if it is 0, my output will be 0. So 1, 0. Now 1, 0 is my net state. Again, I will repeat the same process. Calculate the value of D1. D1 will be AND of Q1, that is 0, and AND of Q2, that is 1. So 0, 1 will give me 0. And D2 will be Q1 value, which is 1. So 0, 1. And my net state will also be 0, 1. So 0, 1. Same way, I'll calculate the value and I see that I get 0, 0 here. Now, we see that there are only 3 possible states this counter can have, which is 0, 0, 1, 0 and 0, 1. So my mod value is nothing but 3. So F will be equal to F clock by 3. So 12 by 3, which is 4 kilohertz. 4 kilohertz will be my output frequency. I hope this is clear. The main thing to remember is the truth table of D flip-flop, that's all, and you can solve it easily. Now let's move on to the second question. The figure shows a digital circuit constructed using negative edge triggered JK flip-flop. So previously it was D and now it's JK. Now here they have given us the starting state as 0, 0, 0, Q2, Q1, Q0 as 0, 0, 0. Now they are asking how many clock cycles are required to again get back the state as 0, 0, 0. This is a circuit. I'll do the same thing. I'll draw the truth table again. So I'll write it as Q2, Q1, Q0. But the values of J and K are J0, J1, J2. So J0, K0, J1, K1, J2, K2, and the next values of Q2 bar, Q1 bar and Q0 bar. Here these values will depend on the values of J and K. So let's see according to the circuit and write the values. J0 is 1, they have given, so J0 is 1. K0 is also 1. K0 is 1. J1 is nothing but Q2 bar. So J1 is Q2 bar. K1 is 1. J2 is directly connected to Q1, so they have the same value. And K2 is 1. So we have all the values. Now let us see. Initially, so now previously I stopped with calculating the values of J and K. We'll see again. J0 is 1, K0 is 1, J1 is Q2 bar, K1 is 1, J2 is Q1 and K2 is 1. So now let us get started. Q2, Q1, Q0 are the states. So initially they are 0, 0, 0. J0 is 1, K0 is 1. J1 is Q2 bar, Q2 bar will be 0 bar 1, K1 is 1, J2 is Q1 value, so Q1 is 0, so 0, K2 is 1, so 1. Now Q2 bar will be 0, 1, 1. How? See, let's see. Q2 bar will depend on the value of J2 and K2. So as we saw, if it is 0, 1, the value is 0. Q1 bar is 1 will depend on the value of J1, K1. So if it is 1, 1, toggle operation. So Q1 was 0 here, it will become 1 here. Same way, Q0 will depend on the values of J0 and K0, which is again 1, 1, so which means toggle. So Q0 is 0, so Q0 bar will become 1. So 0, 1, 1 is the net state. Same way, based on the values of J and K, we can calculate the new values. And we will see, this is the truth table. we will see that after 6 clock cycles, we again get the value of 0, 0, 0. So the answer is 6. Thank you. Please feel free to like and share the video.